Good afternoon, everybody. My name is John Schreiner. I'll be giving you this period of instruction on troubleshooting routing protocols. So just a little bit about me. If you like to do Twitter, I'm at JShrine. You could find me there. And I've got a blog at Unadulterated Nerdery. It's not, sadly, it's not that.
It better be unadulterated.
It's unadulterated, but I'm working on, raising the levels of nerdery on it. But, a lot of the stuff that I'll talk about in this presentation, I've got an hour and 15 minutes, so obviously I'm not going to be able to get super deep, especially covering 3 protocols. But a lot of the stuff that I'll talk about, I have a lot more in-depth articles there, and you can just catch up with me there a little bit later if that's what you'd like to do. So a little bit about me, I think, not to just kind of brag or anything like that, I think if you knew a little bit about me, the presentation will maybe make a little bit more sense. So right out of college, I joined the Marine Corps. I'm still active duty. I'm a Marine Corps communications officer. So I did psychology and a little bit of psychology and a little bit of sociology in college. And I went to the Marine Corps, and they're like, "You're going to be a communications officer." So no classes on that in college or anything like that. I just showed up to comm school, and surprise, here's what a packet is. So that was really kind of diving off the deep end. And after I did communications school, I did a little bit of time. I did a couple stints in Iraq, and just kind of learned what it meant to be a communications officer, which is really just an IT manager. So I'm definitely not going to be the most technical guy that you're going to come across. So kind of keep that in mind. But after I got done with that stint, I got 3 years where I was an instructor. So I got to teach CCNA, CCNP, CCNA security, and they kind of let me get in and out about every class that I wanted to. So I really, got a chance to absorb it all in, and then went back to the Fleet Marine Corps, where we go out, deploy, and check some things out, where I got to put a lot of that stuff into practice. So a lot of the stuff that I'm going to talk about here is going to be really basic stuff. And the other thing too, because I found that really brilliance in the basics is kind of the thing that really routing protocol troubleshooting is all about. Because I just got done with the Jasper not that long ago, and the needle in the haystack, crazy TCP stuff. Routing protocol is a little bit more simple than that. As long as you follow the rules, it's generally not that complicated. So we're going to stay pretty much for the basics in the class. So as long as you know that going in. All right. So what we're going to talk about, or kind of how I've structured the troubleshooting here, is for me, troubleshooting routing protocols is a lot like surviving high school. Okay? You kind of have little phases that you make it through, and as you make it through these phases, and if you kind of break it down and think of them as those different phases, I think it's a little bit easier for you to troubleshoot. So we'll start out with the background. Maybe that's not going to be the most exciting part. We're going to talk about interior protocols, exterior, etc. Yeah.
How to kill the lights?
Oh, you like to kill the lights? Yeah.
His screen's a little
whatever I'll make it for you.
way better.
All right.
Cozy.
You guys are all welcome. Welcome to come in. All right. Hopefully that's better on the eyes. So as I was saying, we'll just go into the background of little bit tidbits that we need to know going into it, and then we'll talk about the first stage, which is making friends. That's your neighbor relationships, and we'll talk about some of the rules of the road and what you can kind of look at Wireshark to help you out with that. Then from there, we're going to go into the passing notes stage. We've made a friend, and now we're going to tell our friend about all that stuff that we know. That's where we're going to pass the routing updates. Then that's when things kind of take a turn for the worse. You've got a little bit of lying going on, or you think you're being lied to, and we got to figure out, are our friends really our friends? Should I be knowing about this stuff or not? So we'll sort out the lies, and then inevitably there is a silent treatment phase, and we'll talk through kind of what that looks like and how to troubleshoot that. So before I go into any of that, does anybody have any questions? Or should I keep kicking? All right. Okay, so at its base, what is it that a router does? Really, a router just moves packets from one subnet to another. Or is that kind of break it down, because I get the question a lot, really, what's the difference between a router and a switch? Switch is looking at layer 2 information, destination, making a choice, and a router is going to look at layer 3 destination information, make a choice. At its root, that's what it needs to do. So if you really just kind of think about destination IP address and comparing that to something in a routing table, you keep that as your primary focus on what you're looking at, that definitely helps to center you, and that's how I like to think about it. So, since we're all centered on destination IP address and the routing table, how do we get stuff into the routing table? Really 3 ways that you can do that. You've got directly connected routes, i.e. networks that you own. You've got static routes, networks that you put in there, and then dynamic routing protocols are the 3rd way that you populate the routing table. Obviously, that's what we're here to talk about today. However, as we talk a little bit later, we'll get into how dynamic routing protocols will get overridden many times, so that's important to mention. All right, so out of those dynamic routing protocols, we break down into 2 main segments. So you've got your IGPs and your EGPs. Your IGPs are your interior protocols. And what I'll talk about in this presentation, EIGRP and OSPF. I know not a lot of people like EIGRP. I'm a huge fan. And in the Marine Corps, that's our routing protocol, so I have to like it anyway.
Who's your vendor?
Surprise. I will get into that a little bit later, too. So with your IGPs, and this is not, you'll find out with a basic presentation like we talked about lies. I will lie to you many times during this presentation, but I am lying with the best of intentions to keep it simple. So, knowing I'm lying to you a little bit, IGP is really all that's concerned about is getting to the destination. You're really not too concerned with, okay, well, I can get to this network, but can I get back? That's not really a concern or consideration when you're looking at IGPs. So really, it's just like out, out, out. It's really all that you're going to be concerned about there, or at least when I troubleshoot, that's really the only thing I'm concerned about. When you get into EGPs, and the only one that's left is BGP, that's where things get a little bit more complicated, because for things to really work, it's not just you getting to where you need to go, but you need to be able to tell the world in BGP, hey, here's where I am. And if you can't do that properly, your protocols and your communications aren't going to work. So it is a little bit of a change in thinking between your IGPs and your EGPs, and that's just something that you're going to want to make sure that you consider. All right, so per the question, who's your vendor? OSPF and BGP are open. EIGRP technically was a proprietary protocol and is no longer. However, if you look into the details, all the special sauce that kind of makes EIGRP cool, if you think it's cool, your stub areas and some of the more diverse features inside of EIGRP, those were not opened up. So basic EIGRP is now an open protocol and can be implemented. When I ask all the different vendors, like, they plan on doing this, what's going on, I'm getting a lot of crickets as far as who's going to put EIGRP in a box that doesn't say Cisco. So we can think of this as like openly not open. So either way, that's to be considered. But since all our boxes say Cisco on it, that's not a problem for me. But if you're looking at, do I want to use this or not, that's a consideration. When we get into tunneling and some other things, we can look at ways where you have boxes that aren't Cisco boxes that you can use that. So with that, talking about inside of your interior gateway protocols, two major different types. You've got distance vector protocols and you've got link state protocols. Of the ones I'm going to talk about, EIGRP is a distance vector protocol. The nice thing about this is distance vector, you got your answer right there as far as how does distance vector work. You can break it down into 2 words. Distance, like how hard is it to get to wherever it is that I'm going, and vector, which way do I go? So unlike, and we can contrast this, finding it out a little bit easier just by saying how OSPF works. OSPF is a link state routing protocol. That's the know-it-all of the protocols. They know how you're connected to everyone, where all those connections go, and it's like you zoom the camera way out and you come way back and you can see everything. That's a lot of information that you have to process, so that's one of the downfalls. So you have, we have little radios that act as routers. You can run OSPF on that, but depending how big your network is and things like that, that's putting a lot of tax on a device that has to run off of a battery. So in some cases, knowing everything and having to think through everything, recompute, maybe that's not necessarily the best option at all times. But the nice thing about knowing everything, as far as the topology is concerned, is you don't have to worry about loops. With distance vector routing protocols like EIGRP, potentially you can have loops. So there's going to be some things in there that make troubleshooting a little bit trickier for us. as far as loop avoidance. I'll make sure I highlight that as well. All right, so that's the basics. Now we're kind of going to get into the making friends stage. So as we're making friends, the first thing we got to think about is we want to get routes into the routing table. The first step towards that is before you can exchange any routes, you have to have an adjacency or a neighbor relationship. Two routers need to come together and they need to say, hey, I want to start peering with you, start sharing routes with you, and you start a neighbor relationship. So after you've formed a neighbor relationship, you can get into exchanging routes. But if you're having problems and you're not seeing in the routing table what you think you should be seeing, normally that's the first place you're going to want to check. Like, something doesn't look right. Am I actually neighbors? Am I friends with the people that I think I'm friends with? That's one of the first things I look at. And kind of the way it works is a little bit different for each protocol. So let's take a look at how that works. So before I go into the nuance, if you're one of those ones, and I completely understand, you like to, cram away GNS3, or if you're a big Cisco guy, if you have Viral, an emulator where you can kind of go through this. All my captures, and I'll make those available for you at a later time, all my captures are using this scheme here until we get a little bit more complicated down the road, and I'll show you a different topology. But you got router 1 with a loopback of 111, router 2 with a loopback of 222, and they're connected with a 192.168 10/31 number. Okay? The nice thing is you don't have to worry about this being sanitized because these are all private IPs, and I just did this to illustrate some of the points for the class. So with OSPF, here's how we make friends. It all starts with a hello packet. So if it starts with a hello packet, how do we get that working? You have to have an interface that's in an up status, i.e. up layer 1, up layer 2. So you got to have a cable connected. You need to be able to come up with a common protocol at layer 2. As soon as that interface shows up, if you put an IP address on it and advertise that network in OSPF, you're going to start shooting hello packets out that interface. As soon as you start shooting hello packets out your interface, and I start shooting it out of mine, we got ships in the night, that is how we form a neighbor relationship. Okay? There's a couple things that can stop that from happening. With OSPF, it's not too complicated. If we have a common link, that common link needs to be put inside the same area. So if it's area 0 or area 1 or whatever, if I'm area 0 on this connection, you have to be area 0 on this connection. That's one of the things that has to match. And then with OSPF, the EIGRP will not be this way, but with OSPF, your hello and hold timers have to match. So as long as those things match, as long as you're in the same area, you've got that advertised in, you're going to do some hellos, boom, we're going to have a neighbor relationship. Pretty simple. Okay. One of the rules of a neighbor relationship for IGPs, EIGRP, and OSPF is you have to be directly connected. Now, you can kind of cheat the process a little bit, and you can use tunnels. So I'm guessing mainly familiar with tunnels. Does anybody need a quick explanation of that, or are we pretty good? Okay. So you either need to be physically connected or use a tunnel to form a neighbor relationship with the OSPF peer. And here's generally what that's going to look like. So we have 1.0 is router 1, 1.1 is router 2. They send out to 224.0.0.5, hello one way, hello the other way, boom, we're good. Couple things that's important to know about that. You can look at the other packets. That's general idea is hello, hello, and then it's, hey, what do you have in your database? What do I have in mine, etc. But really, right at the beginning there is the important thing to know. One of the interesting things is you don't peer off of IP addresses. So I'm not actually sending to you, and you're not actually sending to me. We're both sending to a multicast address. What I have had, normally not with a lot of experienced people, this is an issue, but do not troubleshoot multicast. Multicast, for all intents and purposes, here is not multicast. We'll see in the next slide. Actually, I'll just show you right here. So right there, TTL of 1, that's that directly connected I told you about. You have to be, and since it's a multicast with a TTL of 1, we can call it what it is, which is a broadcast. Okay? It's just a broadcast packet. You don't have to specify who your neighbor is. It just comes right out that way. Okay? The other thing, we already talked about the multicast destination. The other important thing from this slide, outside of the TTL of 1, normally not an issue, but I have seen on congested links the QoS value there. So when you're setting up QoS values, it's normally a good idea to make sure that you remember your routing protocols, because even though you want to give preference to that really important business application or Facebook that your boss is asking for or whatnot, it's probably better that you can route to where they're going. So make sure you give that preference. Routing protocols use very, very little traffic, so as long as you just very small inclusion in your quality of service. But you have to mess up pretty badly to bring down an interface because it's that congested. But again, it can happen. All right, so the thing I told you about, so I always, when I'm talking to the Marines, I say, hey, there's this and this and this, and I go to the point where I see like the blood start trickling out of the eyeballs, and I say, would you like me to show you this? And so, I told you all about hello timers and things like that, so let me show it to you. So you got right here, I said they need to be in the same area. Technically, we wrote in there area 0. It's expressed in IP address form, but that's area 0 right there. And then your hello and your dead intervals are right there. That's really the stuff you're looking for, at least at a basic level. Now, you can tweak a bunch of different things on here and mess it up if you want to. But, set everybody's priority to 0 if you're on a multi-access link or something like that. But for the most part, you take a look at those simple details and you should be pretty good, okay? So, anybody know what why the hello timers would maybe be different, or how that would change? What's that? Well, yeah, you can manually set it, but if you code bandwidths in there, so you code bandwidths on an interface, less than a T1 is going to be slower hellos, faster than that is going to be faster. So, maybe you're doing QoS, maybe there's some weird reason why you're playing around with the bandwidth settings or something like that. If an interface thinks it's slower, it'll send slower hellos. So that's something you'll want to look into if someone's played with that. So you might kind of be sitting in your chair like, why would anyone ever do this? Sometimes there's unintended consequences based on your different employments. All right, so we went through OSPF and how to make friends there. With EIGRP, pretty simple. You typed in router OSPF1 or whatever. That just defined OSPF. That was not important. The thing that was important in OSPF was that area number. With EIGRP, you're going to do router EIGRP and a number. That number is actually important. It's not just locally significant to the router like the OSPF one is. So that has to match. So if you and I are going to peer, if I'm EIGRP1, you need to be EIGRP1. That's the ASN. Speaking of lying, it's not really an autonomous system because, like, when we get into BGP autonomous systems, like you can't just put a number down there. Like, you are given a BGP ASN when you apply for it, and that's a public thing. This, not that. So I don't like that they call it ASN, but whatever, that's what it is. And then the other thing is the K values. I really do not think it's worth getting into the details of the K values. All you really need to know is there's an equation that determines how hard it is to get to EIGRP routes, the distance part of distance vector. You can turn on different variables or different attributes in that equation. That's what those K values are. I'm going to go with the probably you do not want to mess with this. As long as you don't mess with it, all of them, even Cisco is actually consistent in this regard. So if you just leave it go, everyone will have the same K values. And again, just like OSPF, you have to be directly connected. Here's what this is going to look like. Again, that looks exactly like it did for OSPF, with the difference of instead of going 224.0.0.5, we're going to go 224.0.0.10. So just a different multicast address. Another easy way to you can look at a network and you can kind of pick certain things out. You can very easily pick out what routing protocol they're using based on where you're seeing the multicast go to. But all intents and purposes, it's quite similar to OSPF, at least in how neighbors are made. All right, and I actually taught Cisco for 3 years, and I'm a little ashamed to admit I taught this wrong for 3 years. So I told everybody, okay, here's what we're going to do. We're going to do, network statement, and you go out here, and it's a TTL of 1, and you're sending to me, and it's a TTL of 1, and I lied for like 3 years. So hopefully none of the Marines I'm lying to over the last 3 years is reading or listening to this recording.
Are they teaching now too?
The captain lied to me. What's that?
Are some of those guys teaching now too?
I've probably perpetuated the myth.
Just change the standard. And then
I'm just going to go into the router and start having to rewrite the packets. Then I wasn't wrong.
I was right, damn it.
So that's how you do that. And then the K values I talked to you about, they're right here. Again, just don't change that and you're good. And then there's the autonomous system right there. Just to show you, you've got 5 and 15 seconds as your hello and hold timers or hello and dead timers, if you want to think about it that way. EIGRP, you do not have to match. So you can kind of set this up however you want to. A problem that you can run into. So the idea of these timers is I send you a hello every 5 seconds. And at 15 seconds, if you haven't heard from me, I'm dead to you. Okay? So if you play around with them, which you can, you're like, oh, I'm going to be one of those guys that's like super fast convergence. So you're going to shoot the timers way down. If you shoot them down, but I don't, that's a little bit of a problem because, you're like, hey, wait a minute. I'm sending hellos every second, so I'm going to go ahead and call you dead at 3 seconds, but I'm sending them every 5, so what that's going to look like is neighbor established, neighbor dead, neighbor established, neighbor dead. Not good for your internal routing. So as long as you do something sensible with the timers, I've never messed with them and I've never had a problem. All right, so then the next thing is BGP. So EIGRP and OSPF is kind of like, hey, yeah, this is the same as this, and the captures look exactly the same. This is different. First off, it's TCP based. So, your general, and it uses TCP 179. So from any of the other classes that I've been in, everybody's talked about the TCP handshake. They've shown it. So there's no need for me to go over it again. If you put BGP in your Wireshark filter for this, you will not pick up the handshake. So that's just something you want to keep in mind. And the handshake is the first thing you're going to want to troubleshoot as part of the neighbor relationship. So just keep that in mind. You know from all the other classes, so I'm just going to move on from there. The other thing that's a little bit different with BGP is you do not have to be directly connected. This is true, and we'll talk about IBGP and eBGP, but this is true for either flavor of BGP. So since you don't have to be directly connected, some of the assumptions that you could make previously are no longer valid. So like with OSPF, if you gave me a route, it was assumed that I could get back to you to get traffic to that route because we have to be directly connected. So your next hop for me is going to be reachable. That's an assumption with an interior routing protocol. With BGP, this is something that we're going to have to consider. Okay, and we'll get into that a little bit later. The other thing is because it's not multicast out, this is unicast. TCP, you can't just TCP to 224 and just decide who's going to talk to you. This is unicast, and it's TCP based, so you're going to have to statically define who your neighbors are. Or as I like to explain it, nothing in BGP happens by accident, and if it does, that's not good. Okay? So you have to statically define who your BGP neighbors are, and you may kind of want to look into how that happens. We'll talk about that a little bit later. The other thing is you don't have to advertise the link that connects you. So we can peer on 192.168.10, and the way that I set it up in examples, we peer on 192.168.10. I advertise the loopback. Do not peer on the link that connects us. So that's not advertised in BGP. Not a requirement, which compared to EIGRP or OSPF, you can't do that. Because if we don't advertise that link that connects us, we never become neighbors, we never exchange routes, and there's that. So BGP, just the whole premise it operates on is completely different. And then IBGP versus eBGP, this is probably like a class in itself. When I talk BGP, I'd like slam a double-size energy drink and talk as fast as I could for 6 hours. And then you had the very, 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 very basics, and you probably couldn't even configure BGP yet. That's how much kind of like background information is in BGP. So obviously we're not going to get into all of that, but general idea is IBGP and eBGP, they work differently. They have different sets of rules, different forwarding, different way that they share routes. If you're to the point where you're going into BGP deeper than SYN, hack, and checking neighbor IPs and things like that, you need to make sure you have down cold IBGP versus eBGP. And just a quick definition for that is IBGP is when you peer with somebody inside your ASN. eBGP is where you peer with someone outside of your ASN. So an example of why you would do that is why would you IBGP peer since it's an exterior protocol? If you have two routers for redundancy that are connected to the WAN, if one of those links go down, you have a bunch of traffic going up to both of those routers. If your external link here goes down, you want this guy to be able to come over and go out this way. Like the whole point of you having two routers is for redundancy. So you're going to want to IBGP peer so that you know about the routes that he knows about. So in the event of a downtime, you can still get out to the network. So just important thing to know. All right, here's what that looks like. Again, three-way handshake. Got our open message, and then we're going to start talking. Inside of there, we have. So we got IPv4 is what we're doing here. You can do IPv6 inside of BGP if you would like to. And we've got a open message right here. The really important thing, though, is my autonomous system is 1, and on the other hand, I have router 1, ASN 1, router 2, ASN 2. So in this message, you're really just looking at what the ASN is. This BGP identifier is not what you use. I mean, you could if you set it up this way, but that's not what you use as a BGP peer. So, my neighbor statement was not for 222 or 111. It was for 192.168. So keep in mind that BGP identifier is just an ID. It's not necessarily a peer IP. All right, so we got the basics of how all the protocols work. Now we're going to get into how we can exchange some routes. All right. Inside of your routes, depending on the protocol and depending on what each protocol thinks is important, that's going to be what's inside of those updates. I'll talk to you about what each protocol kind of thinks is important. But if we have the neighbor relationship and we pass a route, that's not a guarantee that that route goes into the routing table. An example I like to use, has anybody ever, you're getting ready to go, you're telling your wife, oh my God, we're going to be late, and then she's out in the car and you're like, I cannot find my glasses. And you're running all around the house and your glasses are right here sitting on top of your head, right? That's what you can have happen to you a lot of times if you're like, why is this route not in the routing table? Sometimes it's not supposed to. So you got to, and this takes us back to how are the different routes put in the routing protocol. Anybody ever have a junior admin get into your work and panic when something doesn't work? I would imagine everyone. So having said that, what do people do when they panic when something isn't working and they don't really know how to troubleshoot dynamic routing protocols? Random crap, which includes static routes. I have generally found that Marines, if they're like, oh my God, I can't fix it, they're not going to ask for help. They're going to take the tools that they know, which is IP route, and they start putting static routes in. And static routes can kind of sort of maybe make some things work. So just like your glasses are sitting on top of your head, and you're like, I don't know where it is. Why is it not there? Oh, it's there. So if you put a static route in there, directly connected routes are the most important. Then static routes, then the different dynamic routing protocols. So if someone stuck a static route in there, that's why your EIGRP route isn't in there, because static routes are going to take priority over that. That's all based on administrative distance. So you got administrative distance is 0 for your directly connected, 1 for static routes. You got 20 for eBGP, 90 for EIGRP, and 110 for OSPF. So in the Golf series of logic where lower is better, that directly connected route, and then that static route is going to get installed in the routing table, and that's why you keep show IP route, show IP route, show IP route. You don't see any EIGRP routes. If static routes are already there in place of those routes, you're never going to see them. So that's something you want to keep in mind is, if it's not in the routing table, should it even be there? All right, so assuming we've got through the neighbor relationship, we'll go through real quick how the passing notes stage of OSPF works. So I told you OSPF is the I know everything about everything type of protocol. So they're going to go in there and they're going to say, I have this network, this network, this network. Everybody puts this list together of all the networks that they have. That's known as an LSA. Okay? So inside of that LSA, it's going to say, these are the routes I have. And you're going to do an LSA, and you're going to do an LSA, and you're going to do an LSA. And all of that is going to be combined into the link state database. So everybody's individual routes are put into a link state database. This database may not be different. So all of us have the same link state database. So the concept of who has what routes must be consistent. The thing that does not have to be consistent with link state routing protocols is what you do with that information. Or the best route for me, I calculate the best route to this network, you calculate the best route to this network, etc. So we have to have the same common view of the network. We do not all have to decide to use that information in the same way. Yes?
That's in the same area, right?
Yes, that is correct. You're right, inside the same area, yes. So single area OSPF concept, that is correct. Okay, so inside the same area, all the information has to be the same. Does that make sense to everyone? Okay. Then, from there, if you want to see the networks, so am I actually passing this network or not, you can just clear the OSPF process. Again, not a good idea in a production network, but clear the OSPF process, and then you can wait and see the networks that are being advertised. Okay? That is going to look something like this. So in this case, I advertise, like I told you, the 1.0 and the 1.1 network. I've got a 32 mask and a 31 mask, and then on the right-hand side there you see metric. So metric, this is not distance vector, but the idea of how hard it is to get to a network, that concept still remains, and that's what metric is. So OSPF, the metric is cost, which is based on bandwidth. So my loopback, because it's a logical network, not, in this case, I've got a fast Ethernet connection, which is why it shows it as a metric of 10. So my fake gigabit loopback is got a metric of 1, and then my fast Ethernet's got a metric of 10. Okay? So that's pretty much what is contained in one of, this would be an LSA. Okay? It's a link state update packet, and this is an LSA that basically says the network that I have. All of these within your area are all put together, and that's got your database. With EIGRP, anybody ever heard of like routing by rumor? Is what a lot of times EIGRP is referred to as. So the idea, I got the blinders put on. I've got the left side of the classroom and the right side of the classroom. I've got the blinders put on, and I know to get to all of them, I go through you. And I know to get to all of them, I go through you. But because the blinders are kind of on me, I can't see what's behind here. So the obvious kind of, if you want to think about it as a limitation or a maybe an efficiency, is I don't know how you get to them. You just tell me, it's X hard to get there, or the metric is this. I know you can get there, I don't know how you get there. So the problem that we can have is, naturally, if I don't know how you're getting there, there could be loops. And especially if both of you tell me all the way in the back, you can both get to the same person. So that could be a problem, but it's a lot more efficient than me knowing, okay, how do you connect, and knowing every single link and doing a bunch of math on it. You just tell me, I can get to all these people, I can get to all these people, done. That's how EIGRP works. Okay? Now, OSPF, I told you, the metric was cost, and so it's based on bandwidth. With EIGRP, we've got a combination of bandwidth and delay. Okay? I love this because now when I'm sending something over a SATCOM link, that I have 300 milliseconds of latency one way, 600 round trip for a single hop, I have a way of reflecting that compared to like a microwave connection where I'm in a single digit microsecond latency. That's nice for me to be able to kind of reflect the difference there. Not everybody sees it that way. It also makes it a lot easier when you're doing QoS stuff. So you don't have to mess with bandwidth, mess with your QoS configurations. But that is how EIGRP defines how hard it is to get to a network. A combination of that bandwidth and a delay. Okay? Distractors. So you have something known as a feasibility condition. You go through a Cisco class and you're going to get this feasibility condition, and this is where ears bleed and eyes roll back. All you need to know about this is the feasibility condition, it is looking for loops, but that is only for backup paths. Okay? So there's nothing that's going to backup paths unless you do some fancy stuff. Backup paths aren't going in the into the routing table. It's simply within the routing protocol. So as far as basic troubleshooting is concerned, don't waste a lot of time troubleshooting this. That's just a backup path thing. So if you're going down the road of looking in the feasibility condition or whatever, why something's not in the routing table, that's a distractor. That's not a road that you need to go down. Something that is not a distractor is something known as split horizon. Okay? Split horizon says if I receive a route from one interface, I don't advertise it out that interface. At the top of your head, you're like, oh, that makes plenty of sense. But then when you think about tunnels, like something like DMVPN, for instance, so like I'm the hub router and you're all the spoke routers. So you send me, hey, I have network A.
because it's a multi-point tunnel that we're sitting on here, you told me about network A on this multi-point interface. I therefore can't tell him about it. So all of your traffic, as far as he's concerned, just got black hole. So that is not actually a distractor. That's a legitimate, like, this could be a reason why you're not seeing the routes that you thought you should be seeing. Okay? So split horizon is important to keep in mind. The reason, and you don't have to worry about split horizon with OSPF because it's a loop avoidance thing, and OSPF doesn't have loops, so it knows everything. Okay, inside of my network statement here, or in my update packet, I'm sorry, we have delay and bandwidth. There's a lot of other stuff here, MTU. I've had people tell me, oh, the problem is that the hop count's all messed up. EIGRP does not use hops. You don't have to worry about that. Okay? The main thing that you're concerned about here is bandwidth and delay. And, of course, the length of the network and what the network actually is. So that's what the EIGRP packet looks like, and the update packet specifically, and those are the types of information that you're looking at. All right, with BGP, we have a lot more that is involved in BGP. Additionally, unlike EIGRP and OSPF, that's like metric. Lowest is better, great. With BGP, there is a whole decision-making process. And it would be, I mean, it's almost an entire class just going into what that decision-making process is. So I'm not even going to go into it right now. But some of the concepts that are kind of important to make sure that you know is the way, because BGP is path vector, meaning it's not like hop by hop like EIGRP is. However, it is ASN hop by ASN hop. So as you go through autonomous system 1 to 2 to 3, that's all tracked. So if you happen to go autonomous system 1 to 2 to 3, and then in your AS path there's 1 again, that would be a loop. And that would be an invalid route, and that obviously would not be able to be used in BGP because that's a looped route. Does that make sense? Okay, so that's definitely something that we're going to want to look into. And again, like I said before, next hop may not work. Okay, just a quick scenario here because I'm going to spend too much time on it. The same general idea I gave you about why you have IBGP and eBGP inside your enclave. You have two routers. So I'm connected to ISP1 and ISP2. When my ISP2 goes down, this router over here is told about ISP1 via this next hop right here. That is not something that's directly connected to that router. That's an ISP link, so it's not routed in your IGP. So most likely, your router 2 does not know about that connection between router 1 and ISP1. So that next hop is not reachable. Therefore, none of your redundancy or resiliency in your network is going to work. So that's something that you need to think about and something that obviously needs to be planned for. And that's why we always want to test our redundancy. Pull out a cable, see what happens. When someone else is on shift, though. Inside the BGP messages, now here's where it's even more tricky. This isn't even showing you everything. This is everything for this, but if I was doing, for instance, IBGP, because this is an eBGP update message, if I was doing IBGP, it would be different, and if I put different, like if I put some communities in there or some aggregate addresses, the attributes would go even bigger. So with BGP, another reason why it's different is because your update messages aren't even going to look the same every time. You're always going to have those attributes because you have to have them in there, but there are additional attributes, and again, if you have to get really deep into the protocol and what the decision making is, you're going to want to look and make sure the attributes are right, things like that, but definitely something to be considered. But when I talk to you about the AS path, that's it right there. So if we did AS 1 to 2 to 3, it would be 1 space 2 space 3. Okay, so that's what your AS path looks like. And the next hop answer right there, you can also see what it's advertising as a next hop IP address. If you're having a problem, I would personally do this on a router, just type in show IP BGP, and it would show me all this stuff, and it would even tell me if the next hop's reachable. But if you don't have access to a router, or all you have is PCAPs, you can look at, okay, one of the things I want to know, if I'm trying to get to 1-to-1 and I 1.1.1.1 and I can't, is on this router, 192.168.1.0 actually reachable? Is that a reachable next hop? That could be one of the things that you look into. Okay? But very, very similar, at least down at the bottom there, as far as there's my network with that mask. All right. Now into the sorting out the lies period. Everybody lies. Like I told you, I lie a little bit in this presentation, and we'll find out that Wireshark lies to us with the best of intentions, of course. So here's how some of those lies can happen. So you have filtering. So I've filtered before because I don't want certain routers having private IPs on them. So I filter out all the RFC 1918 addresses. That's one of the things that I commonly do. One, it kind of keeps routing tables in the higher levels that don't need to have those routes, kind of keeps the routing tables a little bit smaller, and keeps me from explaining why is this IP here and things like that. So filtering can take those networks out of a router. The big difference as far as filtering, because you can filter two different ways. You can get rid of all those private IP addresses by just putting an ACL or a firewall in there and saying, drop all of this. It will get rid of all that traffic. Good, bad, or otherwise, that traffic gets dropped. With filtering, all you're doing is stopping from passing a route in a routing protocol. It doesn't actually disrupt any of the actual forwarding of the information. So all you're doing is stripping off information from routing updates with filtering. Okay? Just the opposite of this is summarization. This is essentially you saying, you know what, I'm going to make things a little bit simpler. Instead of taking information away, I'm going to say, I have a bunch of these networks. In some cases, you'll want to summarize because maybe you bought a /22 from your ISP. So you got 4/24s, right? And you're only using 2 of them. Anybody know what happens when you're routing 2 networks but you own 4 of them? It looks something like this. So you're using network 0 and 1, and 2 and 3 are not used. So your ISP sends you network 3. And since you aren't using that, you send it back to your ISP, and then your ISP sends it back to you, and then it comes back. So you loop packets. So
that's assuming when you use the route back to your ISP.
What's that?
Isn't that assuming that you have a default route back to your ISP?
Yeah, that is assuming you have a default route. That's a great point. It wouldn't do that without a default route. However, all of my scenarios, we always use default route. But you could have a looping problem there. So what you can do is you can summarize, and you can say, I own all 4 of these networks. You're actively routing 2 of them, and then the other 2, the 2.0 and 3.0, just get sent to the bit bucket for you. So one, summarization can kind of help you from having your different loops like that. The other thing is it can make your routing table smaller. So that's helpful. Like anything else, this can be misconfigured. I found out I had some people do some summarization for me, and it was done in the wrong direction. You want to have, I had a fun day. It's the network is on fire. And I went out there and was like, what is going on? And all these random things are down here and there, and you're just like, and then the period of calm sets in, and you're like, who changed something? And then they're like, oh, you remember those summaries you asked me to put in? I finally got around to those. Where did you do this? And that all kind of comes in there. So like anything else, even with the best of intentions, you don't want to have a bunch of looping packets and things like that. If done improperly, that can lead to problems with your routing protocols, and that's something that you'll need to look into. Okay, so that's another one. Then the other thing is tunneling. Tunneling is essentially lying about being directly connected, and everybody said they know how that works, so you just add another IP header in there. The big thing there, you're going to need to make sure that you have your physical and your logical networks kind of mapped out as far as how that's all working. Okay, and then the other thing is there's these random other devices. So I told you about how we have little radios that act as routers, and then there's the device on the network that everybody blames for all the problems, firewall. That, in many cases, depending on how they configure it, is also a router. So what can happen is my router's got all the right routes. There's this firewall. Your router's got all the right routes, and we're like, Turns out there's a router in between us, even though we call it a firewall. It's forwarding between different subnets, looking at that destination IP and going on. If they don't have the right routes in there, there's yet another reason. So even things that aren't routers are routers, and yet another way we're lied to. Load balancers, radios, and anything that's routing between subnets, you can have that problem. Accelerators as well. All right, so for sorting out the lies, for my PCAP here, I did another scenario just to make it a little bit more fun. So now router 1, router 2, router 3, the same, 111, 222, 333 loopbacks, and we've got the tunneled network is 172, 1610. All right, so with your inside of OSPF, you want to work through the lies here. Starting with tunnels, the first thing you want to make sure is you want to make sure your transport network, or physical network if you want to call it that, you want to make sure that your transport network has a route between your tunnel source and your tunnel destination. As long as it has a route, and as long as all the different devices between there, as long as your source can get to your destination, you're good. Because that's what the lie is you're lying and you're saying, no matter what the traffic really is, you're lying and saying it's all sourced from the tunnel source and it's all destination of the tunnel destination. So that's the lie that you're telling. But what makes it really easy is, as long as you can route between that set of IPs, you're good. Which, especially you're going across the internet or something like that, way easier to just get between two IPs and have to troubleshoot all that different stuff. So that can definitely be helpful. But it kind of gets you into the mindset of, now I'm troubleshooting two things. I'm troubleshooting a transport network, and I'm troubleshooting my tunnel networks. So start with the transport network. All right, and then with OSPF, your summarization can only be done by area. Remember I told you about the database and they need to match up and things like that? So like one of your routers in there can't randomly decide, I'm going to do things a little bit different. It has to be done by your ABRs. So your OSPF ABR, area border router, is going to have to do the summary for that area. So if you think you have a summarization problem, unlike EIGRP, where you can do that anywhere, which is awesome, but when you're the troubleshooting guy, it's a lot easier to just hop on the ABR and be like, do we have a problem here? So at least you can kind of direct your troubleshooting more quickly. So this lie, even the lie that Wireshark tells us. So you see here, 172.16.10 to 224.0.0.5. This is tunneled, as you can see the tunnel information right there. So even Wireshark is lying to us. The nice thing is, they're kind of giving us really what we want to see, because we kind of want them to say, okay, blah, blah, blah about the tunnel, what's inside of there. So Wireshark is showing us that. However, that's not what's going across the wire, and that's not what, like 172.16.10 and a multicast address is not what's actually getting routed in that packet. What's getting routed in that packet is 192.168 has to be able to get to 192.168.13. That's where you're starting your troubleshooting at. So keep in mind, Wireshark will even lie to you a little bit as far as your tunnel networks are concerned. As long as you have that going in, you should be good. All right, with EIGRP, pretty much all of the tunneled information is all the same. As far as filtering and summarization goes, filtering and summarization can be done in EIGRP anywhere. In the Marine Corps, that's why I really like it, because we generally don't have a, here's what you're going to do for the next 20 years type of plan, so I can set down my core switch and I know it's going to, no, I mean, like, I can go out to the field and I can be gone in a week, or we can go somewhere and told we're going to be there for a week and end up being there for years. So having said that, I don't get to be like one of those brilliant like planner guys who designs OSPF networks. I kind of like down and dirty, drop some EIGRP here, and for now I'm going to summarize here and maybe I'll change it a little bit later. That's a nice thing about EIGRP. One of the problems though is that can make troubleshooting pretty rough, because you can summarize in multiple places and you can do them like back to back if you want to, which can be a little bit of a problem, especially if you mess them up. The other thing is, just taking a quick step back about what happens when you summarize is, and to go all the way back to, put your head in the routing table. The most important thing as far as the routing table is concerned is not administrative distance and then metric. The most important thing is most explicit match. Then you get into administrative distance, etc. So the more precise the mask is, the better it is. So one of the things that we have happen sometimes when we're not thinking through things is, I got two connections out, like maybe I've got a microwave and I've got a satellite link. So I do my summary to the microwave link. What ends up happening? Everything comes in over the satellite, because no matter how bad the delay was set up there, there's like, combining /24s, I've got a /22 this way and 4/24s going this way. This is more specific, therefore that's where all the traffic goes. So it's just one of those things of like, even with the best of intentions, you need to be thorough and you need to understand the difference. With OSPF, you do it by area and it's done. With EIGRP, you can do it anywhere. Great flexibility. I love it. You can have these types of scenarios where you do need to be thinking through what it is that you're actually doing, because you can cause routing issues through the stuff that you do, not just the stuff you don't do. So just something that I would want to keep in mind. All right. The lies are exactly the same with the EIGRP. It's going to show you inside the tunnel, not the actual physical IPs that are coming across there. All right. With BGP, we can talk through BGP tunnel, but I mean the general idea remains. However, one thing I think a lot of people, I don't know if I want to say misunderstand, but you don't, like EIGRP and OSPF, you have to tunnel because you need to be directly connected. I think a lot of people also run under the assumption that because I had to tunnel in those scenarios, I need to do it with BGP, and that's not the case. So when you put a tunnel on there, you know, tunnels are great, they make things magical, but they add additional overhead in there, and you know, you can run into then, and your segment size goes down, and you're being less efficient than, you know. So I would say tunnel when you have to, not right off the bat. So having said that, a lot of the scenarios where in EIGRP and OSPF, you're going to be setting up tunnels because you have to. BGP, that's not the case. You can just go into BGP, even eBGP, and you can say, I'm going to peer with somebody multiple hops away. And in many cases, that's the smarter thing to do. The only issue is that whole transport network needs to have all the routes necessary. So they need to be able to get out to the world, and every hop needs to know the networks that you own. So something to consider. I have always tried not to tunnel if I'm using BGP, but it just all depends. So, but anyways, it's going to look the same when you look at the packets. A tunnel's a tunnel's a tunnel. So Wireshark will show the same for BGP as it does for EIGRP and OSPF. Now here's the thing with filtering. With EIGRP and OSPF, you filter, and like EIGRP, you set up a distribute list or you set up a summary. It's going to quick cycle the neighbor relationship, send that summary out, and everything's good. With BGP, when you set up, if you set up a summary, or if you filter some routes, or you know you put some kind of manipulation in where you want to change an attribute here or there, it doesn't do that. You actually have to. I mean, there's a bunch of different. We don't need to get into it, but you need to recycle that connection in some way, shape, or form. There's ways of doing it without dropping TCP and blah 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 blah. But the general idea is, BGP is not going to do it for you. So here's a scenario. I've decided that I'm going to do this new load balancing thing, and I completely hosed it up. I want to go left instead of right, and I put it all in there. I hit enter, and it seems like everything's working great, and I'm like, woohoo, and I walk off. But I just completely hosed that. Now here's what happens. Nothing. Until we lose power, or the cable between you and I go down, or something like that. So hours, days, weeks. I was running a Cisco router at my house. I had an uptime in like North Carolina. Not exactly the most stable power there. We had like hurricanes and stuff. The uptime was like 2.5 years.
Wow.
So 2.5 years from when my WAN connection went down, or since that router was reset. So imagine you put this BGP fix in, and 2.5 years later, whoops. And I mean, you probably left the company at this point, and now you're like, what happened? And you know, it was a known good configuration for the longest time. So that's the type of thing where if you have somebody doing BGP, that should not be the guy who is starting day one, and you should have some sort of setup put in there to where cycling, you're testing, things like that. But the main thing as a troubleshooter to keep in mind is this does not work the same way as the EIGRP. It's very different. All right, so unintended consequences of that. All right, and the lies there look pretty much the same. Okay, so the last thing that we have is the silent treatment, which is, I thought I should be seeing something, and I am not seeing that something. So what are a couple different scenarios when that happens? Number one is security. Almost all problems are security. Don't tell Jasper and all the other.
Spoken like a network guy.
Yeah, all the other than a million everybody security people here. But most of the time, you know, it's this thing didn't go in the firewall right, or the protocol ports. I've seen this a million times. Do a little research on what ports does this protocol use. Go to the vendor site, get them all done. You're like, okay, I need this and this and this put in the firewall. And you're like, hold on a second. Look at Wireshark data. It's like, like this is not what your documentation says at all. You're using completely different ports. That happens all the time too, so do not trust the documentation. But security things come in there, they'll block ports, or you'll be told, hey, I need you to go ahead and make these changes on the network. And an obvious one we'll talk about a little bit is passive interface. So passive interface, you have all those hellos that are going on, right? You want to be one of those crazies that are sending hellos out every 1 second. Every interface that you advertise on is sending 1 second hello packets. And they're to multi-cast addresses. So your computers, not just your router, your computer, your switch, your everything is just getting slammed by all this EIGRP traffic or OSPF traffic. And you can tune the timers down even lower than a second if you're nuts. So you're getting all this information, and you're like, okay, I don't need this on my LAN. Passive interface says, hey, I'll still advertise that network, but I'm not going to send those hellos out anymore. That way your LAN doesn't get overwhelmed. Well, the problem is, a lot of times you'll get the security update. Everything needs to be passive interface default, which means every interface on your router is now passive interface, and then you, one by one, go in there and say, no passive interface for my gigabit, no passive interface for my other gigabit, etc. That's generally how that works out. However, that's not scripted. So it's humans making these changes, default, adding them in there, and then sometimes you got a problem of you either put a passive interface on something you shouldn't have, or you just didn't go in there and re-enable that, and then that drops a neighbor relationship because we can. And then the last thing is encapsulation, and I'll show you what that looks like. So inside of OSPF, here's what it looks like. Schizophrenic conversation. Okay. Hello, 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 hello. It's like you're talking to yourself. And that's it right there. I put a passive interface on router 2. So router 1 is trying to make friends and getting shot down. Okay? So that's what that's going to look like if you have a passive interface. It should be pretty obvious. And to be honest, I would say 90% of the troubleshooting that I do, when I pull Wireshark out, it's stuff like this. It's like, anybody see anything wrong with that? Like the source IP never changes. That's the type of stuff where, oh, okay, I see what's happening here. That's what a passive interface would look like. All right, and in EIGRP, you're going to have pretty much the exact same scenario. Another passive interface, it's going to look exactly like that. All right, and then the last thing, and the last section that I have for you is inside of BGP, you just have nothing. That's a great feeling inside of BGP. When you configure it in the first place, it takes forever. Or as I like to think about it, there are certain things in my life that I want to happen, and they happen right at about, this is my tolerance, and then here's my furious level. It's like furious plus 1 is when these events happen. That's when BGP starts up. So, neighbor, da-da-da, remote AS, da-da-da, put it in there, enter, and you're like, oh my God, 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 come on. And then he's like, I know it's broken. I'm going to start looking through, and then it comes up. So, you're having your woosah moment, you're waiting, and you're waiting, and you're waiting, like, nope, I'm a pro, I've done this before. And then, you're in a couple of minutes, and you're like, don't worry, it's going to happen anytime. It doesn't. Here's a couple of reasons why that's going to happen. Number one, you have to be able to route to your BGP neighbor. So since next hop is not a given, and since it doesn't have to be directly connected, if I have to go through you to get to you, then I need to have a route to the network that connects the two of them. If I don't have that, it's not even going to send any packets, and it's not going to give you the hey dummy, you were trying to get me to do a thing that's not doable. It's not going to give you that message. It's not going to send any packets out. Yes.
Usually in situations like these, if BGP is not coming up because it can't establish the session, wouldn't you be also watching the logs in the other window while it's sending open hellos, or it's not even active, so TCP hasn't even set up, or I can't even say it will yell at you and tell you why.
So which logs are you referring to?
So I'll have 2 terminals open too, and BGP statement, I just hit go on the router and I watch the logs, and show logging messages, whatever, grep BGP.
Okay.
And you'll see oh, I couldn't come up because open.
Oh, yeah,
oh,
yeah. If
AS
you're-
mismatch or whatever.
Sure, yeah. If you're going through, but I'm saying
That
it's,
way
like,
you're not like,
it's not going to
"Ah!"
send you.
You know.
It's not going to send you a console message that says hey,
No,
it's not
no,
reachable.
no.
That's
You
not
have to
reachable.
look, but,
Yeah,
but that way
right.
you'll know. Oh, wait, maybe I better tell it on TCP 19, whatever,
Yeah.
179, or oh, maybe I better.
Yep, yeah. There's definitely, you can definitely find it. You can dig in there and you can definitely find it. You can do some debugs as well. But I'm kind of like going more towards the like just general, like not too experienced guys, and you're like, something is not happening. What you
Sure.
can very easily do is Wireshark that connection, and if you don't see any messages at all, there's no TCP sends, you don't have a route to that network. The other thing that you can have is you can have encapsulation problems as well. So without a route to the network, or and you will actually see you'll see some traffic with this, but if you source from the wrong IP address, then you're going to go across there. You're going to try to set up a relationship, and because BGP is static, you have to peer with the IP address that you said, and whatever they said your IP address is, it has to be that one. It will not accept like, what about this other one? It has to be statically set up. Yes.
So in the conversation here, you're basically looking about how the routers peer up to each other, exchange routes, and do all this kind of stuff.
Yes.
In practical terms, are you using kind of tabs that you're putting in front of these interfaces directly to be able to see these conversations, or how are you acquiring the data?
Okay. Did everybody hear the question? The idea is, how do I see this? How do I see this information that I'm talking about? There's a couple different ways. In a lot of my scenarios, DoD, we have to do encrypted crypt. So one of the ways that I can do that is, you talked about you can go through logs, and there's things you can do on the router. The other thing that you can do is the router has an embedded capture capability, and I've got a post on my blog shows how to do all that stuff. And that's one of the things that I do, just because it's a little bit easier for me to look at a PCAP, and a lot of times I can't be there.
Exactly.
So, I'll say, hey, go to my blog, do this thing, run a capture real quick, and just send me that, or something like that. So the embedded capture on the router is good. If I can do taps, I had one scenario where we're just going to say things were kind of ugly. And this is probably not the best way to do it, but I like cascaded taps and a couple laptops. And we were under a time crunch. So it's like, DNS is not working, go. And it's like inside the firewall, outside of the firewall, outside of the edge router. And we just watch the packets cascade across the screens. And it's like, 1, 2, it's a router.
That's interesting. So you
yeah.
just have like 8 laptops. You wait and
Yeah.
go, well, it's not there.
Yeah.
Found it.
Yeah, when you were in the
That's great.
middle of nowhere and the computers are not working, you would not imagine these
Oh my
things
God.
happen.
Those are the best stories you're bringing up.
Yeah,
These are great.
and I'm not advocating for that's like the right thing to do, but hey, sometimes it's the right thing at the time. So if you can tap, that's nice. I generally don't have that option because a lot of our stuff's encrypted. But you can tell the router, why don't you send me that before you encrypt it? And that's an option. So that's one of the ways that I do it. All right, and then I think the last thing is EIGRP and OSPF. Again, speaking of things I don't recommend you do, you can just type in net 000, enter, and every active, if you want to advertise everything that's on the router, that'll just go ahead and advertise every single network that you own on that router. The moral of that story is EIGRP does not care how specific your network statement is. If it catches an interface or multiple interfaces, it's on there, you're good. BGP, not so much. BGP has to be exact. So if you've got an interface, like if you own a /24 from the ISP and you have that broken down into 2/25s, you can't type in net, your /24, net ID, mask, and a /24. That will not work. Because your router is going to be like, I don't have a /24, I have 2/25s. With EIGRP or OSPF, that wouldn't be a problem, but with BGP, it will not accept that. Are there ways to cheat that system? Yes. However, it will not work with a network statement, at least, unless you have a specific match on the mask. So you look through your configs, and you're like, I don't get what the deal is. It's up. I've got to, SYN act, and the neighbor relationship's good. I'm even advertising some other networks, but this is not working. an explicit mask is required. Yes?
Listen, basically the point is that BGP will verify in the routing table if it has an IGP to the route.
It has to have an IGP or a route.
Oh,
So it doesn't have to be, but yeah, it has to have a route and it has to explicitly match the mask. Exactly. Yes. So any questions on that, or pretty good on BGP? Awesome. All right, here's an example of what that looks like. I didn't do the tunnel this time. This is when your security guys hate you. So this is where BGP is being blocked. So I went in there, I put in the middle router, I just said block TCP 179 and let everything else through. However, I left ICMP unreachables on. So in here, this should be obvious. It's like, I hate you, I hate you, I hate you, I hate you. It's really nice though when people just come out and say I hate you, because down here is where it's passive aggressive. They hate you. They're just not saying. They're looking at you like we're friends. The same exact thing happened here. This one is I left unreachables, and this one I turned them off. So if a firewall, for instance, is filtering 179, that's one of the things that can happen.
It's the difference between drop and deny.
Yeah.
So in the DoD, is the network engineers and the firewall security guys, are you in the same office or the same room? Or is there like this, is it difficult sometimes to build stuff because security aspects, firewall stuff is in a different team or a different...
So the question is, in case everybody didn't hear it, like, do you guys in the DoD have the same siloed problem that we have? And my guess would be it's probably an answer that's very similar to any of the rest of you, is like, what's the mindset of the leadership? So one of the disadvantages of like the position that I'm in is I don't generally get to, if I'm in a router, there's a problem. If I'm running Wireshark for purposes of fixing a network, there's a problem. Because I'm not supposed to be touching anything. It just so happens that happens sometimes, not normally. But one of the nice things about my position is I can just say, we're not going to do that. So a lot of people say we're going to have a server team, and we're going to have a LAN team, and we're going to have a WAN team, and we're going to have a transport team. And all of them kind of like do their own thing, and inevitably what happens is like Marines are a prideful bunch, like I'm sure anyone else is. So we're very prideful of what we're doing, and who's going to be the guy that's going to reach across the aisle and go through that entire thing and have that problem? Mm-hmm. So, in my opinion, it's all about the mindset of the leadership. There's nothing that says that you have to do that. Mm-hmm. I have seen that before. I'm like, are you kidding me? Like. The guy who's running BGP is not touching any of the IGPs, is not touching the firewall. These are 3 different teams. Like, are you crazy? That doesn't work for me. Other people think I'm nuts because they're like, no. You can't have operations guys anywhere near a firewall. Okay. So it's all just, I wouldn't say leadership philosophy. Yeah. There's nothing black and white that says you have to do it or don't have to do it. Mm-hmm. But I personally find it's just better if I'm in charge of everything, and and
then equip a team that's in charge.
Well, if I'm in charge of everything, all the different sideload teams work for me. Yep. So it's like, okay, if we have a problem, it comes down, and then I can say, okay, well, you guys work with these guys or whatever. But depending on how siloed they are, and that's what happens when you have more leadership. If there were more officers involved, this could have been a problem.
And you all are armed.
That's true.
It's rough.
And you all are
armed with my TO weapon of a clicker.
Yeah.
So that's definitely something that we look through as well. And I'll leave you on a positive note. Check this out. So
they had to post the sign.
Let that sink in for a second. This is on a U.S. Navy destroyer, which Marines are ridiculous. I will 100% admit that. However, this is on a U.S. Navy destroyer where there are no Marines. They made a placard. Like, someone didn't pasty up a little sign that said, "Don't eat the urinal cakes." They made a placard that says, "Do not eat the urinal cakes." Like, how bad of a problem was this? That they had to make a placard because it's this bad.
It happened enough they decided to keep it permanent.
Yeah, I'm sure what ended up happening was people got bored and made a competition of it. All right. What's that? Oh my God! All right, that's pretty much everything that I have prepared for you. I'm sorry, you got a question?
Yeah, do you have any other just great stories about the nuances of having to set up these ad hoc networks in the middle of the dust?
Yeah, I've got some pretty good ones. So I had a time where it was, yeah, you if you don't want to hear C stories, please, you're not going to bother me if you want to get up and leave. So I'm out in the middle of the field. It's like 110 degrees or something like that. I'm working in a tent. Every opening, because we have openings in the tent to pipe ACs in there, every opening has an AC. I got that thing blasting full bore, and I got my servers, my routers, my switches, my SATCOM gear that I need inside of there, and the temp is just rising. And it's up and up and up and up, and there's nothing I can do. I can't put anything more in there. So we go into VMware, and we do the exact opposite of what you would think is a good idea, which is we shut everything down. Like, we left one server on, but we shut all the other ones off because we don't have enough AC. And we also have our entire topology running off of generators, which no matter how well you try, those things go down. And the other thing is, as it turns out, it's pretty complicated to have a essentially automatic failover of generators. Generators are not BGP capable. It's very sad. So you basically have to lose power, and then you come back up. So when I talk to a lot of people, and like I would have liked to do Lisp and OTV, and got just crazy in here with some ECMP stuff. But realistically, I mean, the biggest thing that I'm concerned with most of the time is can I cool all of this crap that I have to put online? So for me, it's all about I'm not running physical servers for anything. Everything needs to be virtualized. I want to know how small I can get it. I want to know how little power usage I can have. Okay. Look at an SSD. Some people thought it's a little nutty. Look at an SSD power consumption wise. Forget, yeah, they're fast, and that's awesome. Power consumption wise, that's way, way low compared to spinning disk stuff. And I'm saving that twice, because it's the power that it uses, and then that power produces heat, which I'm using power again to cool down. So every little bit that I can chalk down on power is a big deal. So while it's pretty awesome to get into CCIE level and nerd stuff, and I love doing that, sadly, the thing that really I spend most of my time doing is how can I make it so this isn't so hot? Or how can I make it that I can drop this and not lose all these months of work, So definitely stuff like that. I had a Marine one time. I had an EIGRP flat. And so we're oh, is it stuck in active again? Damn them and EGP, damn them and their EIGRP. So we send this Marine to go down and see why this router keeps flapping. And so he goes down there and he looks around the thing, and he puts his hand on the rack and shot back. And it turns out the switch was flapping because it was ungrounded, and there was a bunch of stuff in there, and the power there was not so safe. So all I'm going to say is...
We don't have these problems.
Yeah, so, sometimes neighbors go down because people get electrocuted. Which I did not include in the slide.
Thanks so much.
Thank you very much.